Hello, everyone. Thank you for joining us today in the fifth lecture of the third edition of the Current Topics in Heritage Science Lecture Series, which is organized within the E-RIHS Academy. My name is Emma Paulin, and I'm a PhD student at the Heritage Science Laboratory at the University of Ljubljana. Today's lecture will be by Lucia Burgio, the lead conservation scientist at the Victoria and Albert Museum in London, where she heads the science laboratory and guides the scientific analysis of the museum objects. She has a chemistry degree from the University of Palermo, Italy, and a PhD in chemistry from the University College London. She is a fellow of the Royal Society of Chemistry, where she chairs the AMC Heritage Science Expert Working Group, using her position to promote the role and importance of analytical science in the cultural heritage sector and disseminate heritage science to various audiences. Today, she will talk about the analysis of Indigenous American objects from the V&A Collection. During the lecture, you can write down your question in the Q&A section, and they will be answered by the speaker at the end of the lecture. The recording of the lecture will be available on the E-RIHS YouTube channel. At the end of the lecture, we'll also receive a survey to express your feedback. If you have any technical difficulties, let us know through the chat. Lucia, thank you so much for being with us today. The floor is yours.
Thank you, Emma. I'm going to share my screen now. So let me know if it works. Okay. Perfect. This time it's working. Can you see it?
Yes.
Perfect. So, thank you for the introduction. Good afternoon, everyone. You may not have heard of Indigenous American lacquer yet, but for the past 20 years, various groups worldwide have been engaged in researching it. And the V&A, which is where I work, is one of these institutions. So what I want to do now is to give you a good context for this presentation webinar. Objects made of Indigenous American lacquer have only recently begun to receive the international recognition they deserve. The V&A has the largest public collection of these objects in the UK and is actively researching them using advanced analytical techniques within a multidisciplinary framework. The scientific analysis and technical examination of these objects is being bolstered by curatorial, conservation, anthropological and sociological expertise, and the results are being shared widely to bring the world's lacquer community together. Now, the question I am putting on the table today is, from a heritage science perspective, what is the best analytical approach for objects which are both rare and not yet fully understood? So this webinar will showcase the research carried out so far at the V&A and will highlight the most recent discoveries and conservation approaches. So this is what I'm planning for the next few minutes. I will give you an introduction to Indigenous American lacquer. I will describe the methodology we have used at the V&A, including our protocol, and I will show you some case studies and explain how they are essential to provide a better understanding of the materiality, genesis, and context of these objects, which can easily sit undiscovered and unrecognized in many collections. It did happen to us at the V&A. But what is Indigenous American lacquer? The most famous one is probably barniz de Pasto, or varnish from Pasto, which is a city in Colombia, which is made with mopa. Mopa is obtained from a plant that grows mostly in the Andes in South America. The leaf buds get harvested, boiled, cleaned, and then made into a sort of cling film that can be colored and applied onto objects as a decoration, providing a lustrous, durable coating. The other famous type is Mexican lacquer, which has been used since pre-Hispanic times. This coating is made of chia oil, which is sometimes combined with an insect-derived material known as aje, and then mixed with pigments. But there are so many other Indigenous American lacquers types from different regions in Latin America, and we don't even know them all. This one that you see on your screen is from South Brazil and is obtained by treating the fruits of the Crescentia cuyete, or calabash tree, with cumatê, a natural dark red pigment which becomes black when treated in a special way. And here you have a selection of different forms of Indigenous American lacquer objects from the 17th to the 21st century. This gives you an idea of all the different types of objects you can find in collections. It's not a straight plain type. And if you want to know more, you can look at the special issue lacquer in the Americas. You have two links at the bottom of your page, of your screen. The first is the special issue itself with links to each article. And the second one is the actual printed book. At the moment, it's only PDF. Very serendipitously, the book was finished yesterday afternoon in perfect timing for today's webinar. And the physical printed books will be available in a few days if you want to buy them. Now, going back to lacquer, locally, the knowledge of these materials never really went away, and artists continue to this day to produce a small number of lacquer objects. And you can see here contemporary artists are working in Colombia, Brazil, and Mexico. However, there was little awareness of this in museum collections and academic circles, and very often Indigenous American lacquer objects were mistaken for something else and mislabeled. Imagine that one of the trays that you'll see today from the V&A collection have been catalogued as Persian, basically a completely different continent. Then about 20 years ago, many groups worldwide began undertaking technical analysis of these objects for multiple reasons. To fill a knowledge gap, we needed to write object labels and record what the objects were made of. And it's also curiosity for its own sake. They are relatively unusual objects, at least from our perspective. We wanted to make sure that the conservation and preservation approaches were tailored to the materiality of pre-Columbian and early modern objects. And we also wanted to provide information to current artists to replicate historical recipes and procedures, which may have been lost over time. So for barniz de Pasto itself, various groups in both Europe and America are using conventional techniques to identify mopa and also which particular plant it may come from, but also pigment, dyes, and metals. This is less trivial than it sounds, as I will be showing you in a few minutes. For Mexican lacquer, in addition to the conventional techniques, researchers at the Met, but also in other institutions, are looking at using different types of omics, proteomics, lipidomics, and all that kind of unusual stuff to identify chia oil, aje, or aje fat, and all the additives that can be present in Mexican lacquer itself. So I'm going to jump straight into the first case study because it gives me the perfect opportunity to discuss the analytical protocol and the many techniques that can be used in this type of investigation. My journey and that one of my colleagues at the V&A began in 2015 when the V&A acquired a table cabinet decorated with barniz de Pasto. And you can see it on your screen is the cabinet as it was when it entered the V&A collection. At the V&A, we, the scientists, not we, the people, do not work in isolation, but we are part of what I like to call, very cornily, the magic triangle, which includes also conservators and curators, and where appropriate, also people from other disciplines, like such as anthropologists, historians, makers, artisans, and so on. At all times, all of us at the V&A were, at the time, all of us who were involved in this project were pretty much barniz de Pasto virgins. Therefore, scientific research and technical examination of the cabinet was planned to find out more about these rather unusual objects and to inform its conservation because it needed some TLC. As per our conventional protocol for any type of object, we gave priority to non-invasive, non-destructive techniques, with one exception, which I will discuss in a minute. And obviously, the order of the techniques can be tweaked as needed. So I will go briefly through each of these to give a rationale for their inclusion in our protocol. You also need to bear in mind that we collaborated with external partners to get access to additional techniques which we did not have in-house 10 years ago. For example, micro-CT, we used it at the Natural History Museum, XRF, we used it at the National Gallery, XRF mapping rather than XRF, and different types of chromatography for which we asked for the MFA, the Museum of Fine Art in Boston's help. We started with UV light and visible light mostly breaking light, to inspect the surfaces, get a first idea about coatings and varnishes, damage, retouchings, conservation interventions, repairs, and restorations. You can see here the cabinet under UV light showing the patchy non-original varnish on top of mopa. We continued with X-ray radiography to check the structural integrity of the object, the methods of construction, any unseen details and hidden damage, all the nails that you can see very clearly in this image, and so on. Infrared reflectography gave us information on any under drawings, if present, and also details hidden under the surface, and on the presence of retouchings, conservation interventions, repairs, and restorations. For the cabinet, specifically, we continued with conventional point micro XRF to look for the elemental composition of individual spots, in our case, pigments, metal fittings, fillers, and repairs. And the next step is normally a nice to have rather than an absolute must. Having said that, in the case of the cabinet, microcomputed tomography was absolutely crucial. And I will show you why in a few minutes. So instead of showing an image of the cabinet here, I'm showing you one of the images obtained from another object from the V&A collection of mopa items. We were lucky to be able to collaborate with the NHM across the road from us, and their micro-CT results gave us a sense of the 3D morphology and the composition of the object. XRF mapping gave us the elemental distribution on both the surface and below it, and allowed us to visualize retouchings and restorations, and occasionally gave us also structural information as well. And on the screen you can see the LED map that represents and shows us where the early restoration is present. Digital microscopy gave us high resolution images, always nice to have, allowed us to appreciate details, tool marks, surface damage, but also to reconstruct the manufacturing technique and get accurate measurements when needed. The exception I was referring to earlier is FTIR, because it's a destructive technique. We needed to take a sample in order to analyze it. So we did take the sample before deciding whether to acquire the object, because we needed to know if this cabinet was indeed made of a material that we believed we did not have in our collections. We did, but we didn't know that. In general, we use this technique when we need information on the binding medium or varnishes and coatings of our indigenous lacquer objects and others as well. Looking at other invasive approaches which were considered necessary at the time, we took samples from areas of pre-existing damage, prepared cross-sections, and analyzed them by optical microscopy to evaluate the stratigraphy and the materials in it. And on the screen you can see one cross-section viewed under visible light at the top and UV light at the bottom. Raman microscopy was used primarily to identify pigments and dyes, well, some of the dyes, and indirectly through the identification of those to put together a chronology for the restoration and later interventions of the object. Now, different types of chromatography can be used to understand better the materials and in the various layers, especially lacquer, organic dyes, binding media, varnishes, and coatings. We don't have separation techniques at the V&A, sadly, and in this case we relied on Richard Newman at the MFA in Boston. Wood ID can help to trace the geographical provenance of the substrate and make comparison between objects. And last but not least, there is, of course, SEM-EDX and micro-XRD, which are good for the evaluation of the stratigraphy in cross-sections and for the identification of materials in samples in general. For the cabinet, most of the analysis details and results have already been published, and I will show you a list at the end of this webinar. But I will recap some of them here, some of these results, to give a sense of our analytical journey and show you the protocol in action. So, The preliminary scientific analysis of the cabinet immediately revealed the first groundbreaking surprise. Mercury in the form of calomel, which is mercury chloride, was everywhere on the cabinet, and we soon realized that it had been used as a white pigment, which we refer to as mercury white. At the time, this was the world's first identification of mercury white used deliberately as a pigment, and it was a big thing, at least for us. At the same time, at least 2 other occurrences in objects unrelated to mopa emerged, a manuscript and a portrait miniature, and since then there have been many related finds of mopa objects. For American lacquer, we sort of opened the floodgates of looking for mercury white and finding it. The Raman analysis of the artist's materials on the inner surface of the lid showed that 20th century pigment, including titanium white, phthalocyanine blue, PO5, PY83, had been used extensively. Now, the first manufacture date of PY83 indicates that the new scheme was applied in or after 1958, so quite recently. And you can find the citation to our relevant papers at the bottom of this slide, and then again at the end of the webinar. I'll repeat it again. X-radiography of the lid, again done as a routine thing, revealed the second surprise. The inner surface included a large skeleton and smaller intricate motifs that were not visible to the naked eye, were not expected at all, showing that at some point in the past, a very different pre-existing motif had been thoroughly covered with a different layer of paint. And here is a close-up of the X-radiography showing the skeleton at the center. Micro-CT, we chose it because we needed to find out more about this skeleton, and it gave us a better glimpse of the skeleton and the hidden decoration. And finally, the mercury map obtained through scanning XRF at the National Gallery first, and then more in detail at the V&A, showed that the underlying scheme is indeed there, which is believed to be original, as the main original pigment everywhere else on the cabinet is mercury white. So it makes sense that what we are seeing with the skeleton and everything else is part of the original decoration as well. Now, the combination of many analytical techniques gave us the opportunity to reconstruct the timeline of the cabinet and many of the repairs. For example, the mercury map at the top shows what is believed to be the original decorative scheme, which is partially damaged or lost. So wherever you don't see any mercury or any gaps in the scheme, it's an area damaged. The map in the middle shows us the calcium-based fills and repairs, such as cracks and nail holes. And the lead map, which I showed you earlier, shows us an old restoration campaign. If we look at the titanium map, that one effectively gives us an idea about the 20th century interventions. Now I will show you how the scientific analyses supported conservation work by my then colleague Dana Melka. Removing the non-original varnish became the focal point of the initial treatment. You can see how obscured the surface is, and the treatment was generously funded by Georgia Welsh Works of Art. The mechanical removal of the varnish was explored first because some of the varnish was degraded enough and friable and could be brushed away with gentle pressure, but not all of it was equally degraded and easily removable in the same way. Solvent removal of the coating was required. Gels were cautiously trialed to limit solvent exposure, and a 2-part gel treatment was found to be most effective. And this was specifically tailored by Dana, taking inspiration from other methods used for different types of materials. The gel really worked to treat, as you can see from these images, and we finally got to see the original surface without the obscuring discolored varnish, and it made a really huge difference. Careful attention was paid to confirm that the mopa itself was not being damaged during the varnish removal process, and at no point did any color other than murky brown, which is basically the varnish, appeared in the gels or in the swabs used for rinsing. And once the varnish had been removed, overpaint, fills and general damage to the surface became more visible. Now, from this slide, you can see the impact that the cleaning of the non-original varnish had. We can really see what the decoration is like, what the colors are like, and before we couldn't. While the overpaint, the lead-based paint that I was talking about earlier, did soften during the varnish removal treatment, it did not solubilize and was left intact in most places. The area under the talon of the bird on this slide is an exception. During the varnish removal, it became clear that a skull had been overpainted and could be easily revealed. You can see here the skull, and it wasn't degraded much. So this is where the discussions with curators and historians were crucial, because in the end, the skull was an essential part of the original iconography, and we decided that it needed to be uncovered. We had the same discussion times 100 about the lid, and it was decided in the end that we should remove the late 20th century overpaint, and you can see here the big reveal of the original surface, retouched where necessary. And this is the closed cabinet before and after cleaning. You can see the difference is quite dramatic, and is even more dramatic when you look at the inside, which I'm not showing here. At this point, we still thought that we had just the one barniz de Pasto object at the V&A. However, the presentation of the findings that I just showed you to colleagues at the V&A led to the reassessment of 3 gold flasks with decorations strikingly similar to that of the cabinet. The flasks have been part of the collection since the 19th century, so quite a while, and were in excellent condition and offered no suitable areas for sampling and destructive testing, except for one case. You can see it's on the right-hand side of the screen, where there was an area of damage and we could take a sample for cross-sections, well, one cross-section, and PyGCMS, which was done at the MFA in Boston and confirmed the presence of mopa. Not that we had any doubt, but anyway, it's always good to confirm your idea. We also verified that mercury white is the white pigment of choice, and in these 3 XRF maps, you can see in sky blue all the areas that contain mercury, and it was mercury white rather than vermilion. And the micro CT scan showed what appear to be mini air bubbles under the mopa surface, which are likely areas of weakness, where the decorative layer would be easier to detach and be lost. Following the acquisition of the cabinet and concurrently to the rediscovery of the gourds, a barniz brillante casket was acquired by the V&A. The brillante technique varies from barniz de Pasto because silver leaf is used under the mopa layers to give a glittery finish to the surfaces. XRF examination strongly correlated this casket with the decoration on the table cabinet, as all the opaque white areas contain only mercury and chlorine, indicating the presence of mercury white. Again, 5 barniz objects, 5 mercury white occurrences. And then, because there's never enough mopa in a collection, we rediscovered 2 more barniz brillante objects within our collections, although the one that you see on the right is still in storage and is due for analysis at the end of this year. So this is the full collection of mopa objects at the V&A, which now includes pieces made by contemporary artists that are you can see on the right-hand side of your screen. So we started from 1, we thought we had 1, we discovered we had a lot more, and we acquired more later. I think you had enough of mopa, so let's go to Mexican lacquer. It may look like barniz de Pasto in a few cases, but only at first glance. The 2 types of lacquer are very different. Here you have a few examples from all over Latin America. And these are the 3 bateas, well, basically large dishes. They're about 45 centimeters across in the V&A collections. In this case, the analysis protocol was slightly different from the one that I showed you earlier. We started with everything we could do in-house non-destructively and non-invasively, infrared reflectography, different types of XRF, stereo and digital microscopy, but we did not do X-radiography. Then we were allowed to take samples from areas of pre-existing damage, and we prepared cross-sections, which were then analyzed by optical microscopy, Raman, SEM-EDX, and FTIR. Ideally, the protocol would have included chromatography, would ID, proteomics, more in this in a minute, but we did not have the opportunity to do it. And this is the first time, apart from, I think, the second or third slide, that I'm mentioning the omics. Traditional analytical techniques in our arsenal, such as FTIR and GCMS, have limitations in distinguishing chia oil from conventional oil, such as linseed oil. These methods are also non-species specific. And this is where the omics come into play, and we hope to be able to use them soon. In a nutshell, proteomics give us ideas about the proteins in order to identify binders and other organic components. Lipidomics examine lipid profiles to detect things like oils and fats. Glycomics look at carbohydrates to understand the presence of polysaccharides and sugars. Our observations gave us the opportunity to verify the inlay technique of the bateas. This inlay technique is labor intensive because each application of lacquer requires burnishing with a soft cloth before completely drying, a process that can take several days. The same process was applied to incised cross hatching, which was then filled with lacquer of contrasting colors. In this case, we have a wood substrate, which is covered in a red preparation layer. This is engraved. The engraving is filled in with dolomite, and then the black background and the pigmented designs are applied where needed. We could not stop at the scientific evidence alone, not for things that are not very well known, like these objects, but had to compare our evidence to the historical sources and the knowledge and practice of living artists. There is still much that needs to be investigated, apart from the obvious composition of the organic mixtures, for which we need, chromatography and possibly the omics. We need to find out more about the pitting we see in some areas. You see it on the left here, perhaps caused by the formation and loss of metal soaps, and the possible presence of diatomaceous earth in the foundation layer. And one last slide. On a different type of lacquer. As I mentioned before, there are many other lacquer types in Latin America, and we do not know them all. Even the ones that we know about, such as the lacquer documented by Renata Maria de Almeida Martins, which you see on the screen, have hardly been investigated from a scientific point of view. Although recently there was a paper by Tiago Puglieri about colorants from the Amazons. We have a few specimens new at the V&A, donated by Renata herself, and we are hoping to be able to start our investigations on them soon. So, in the end, what are the things that I would like you to take away from this presentation? The first and last thing that I tell myself and my team is to be very Socratic. Know that you know nothing. Have no assumptions, do not rely on experience, and question everything you see. That's the best place to start. For example, if we had assumed that an opaque white pigment was bound to be lead white, we would have never done the analysis that revealed that it was mercury white instead. The analysis protocol I showed you today can and should be tweaked as needed, and we really do need to raise more awareness in collections. There must be more Indigenous American lacquer objects around. We simply do not know how to recognize them. Hey, we had 6 and we didn't know we had them. And the same thing must be valid for at least some other collections. So I promised you further reading. You can see a good list here. As I mentioned before, yesterday the PDF of the book reprint came out in perfect serendipitous timing, and there is a link for that too here. And finally, my thanks to all the people who have contributed to the research shown today. I'm bound to have forgotten someone. I hope they will forgive me if I have. And I must give a special mention to Dana and Nick, who were part of the V&A Indigenous Lacquer core team from the very beginning, and they are shown in this picture. And I think that the organizers can take it from here.
To invite you to the next and the last talk of our series of this year, of the third edition, that will be on the 19th of June, and it will be delivered by Jennifer Pauline, and she will talk about pyrolysis GCMS in heritage science.